In the US, there's a concept known as Homeland Defense. The Department of Defense, DoD, defines this concept as the protection of US sovereignty, territory, domestic population, and critical defense infrastructure against external threats and aggression. In other words, Homeland Defense is what guards the US against military invasions, acts of terrorism, and chemical and biological threats. But what happens if the threat in question is something as devastating as nuclear attack? Could the DoD, and the entire US, protect its homeland in the event of such a strike? Until recently, this question was more of a theoretical concern, as the likelihood of a nuclear attack on the US seemed remote. But then Russia invaded Ukraine, even though experts dismissed the idea that this would ever happen. Meanwhile, North Korea amped up the development and testing of its nuclear capabilities, and Iran, whose nuclear program is widely feared, attacked Israel. With some of the world's biggest and, let's be honest, most unstable nuclear powers engaged in full-scale conflicts and throwing out nuclear threats left and right, a nuclear attack on the US can no longer be dismissed as improbable. What was once a distant possibility now looms ominously close, casting a nuclear shadow over the nation's security. So let's ask again, can the US defend against a nuclear attack on its soil? If you're looking for a short answer, we must disappoint you. This question can't be answered with a simple yes or no. But why? Because the US's ability to defend itself against a nuclear strike hinges on several factors. Chief among them are how many nuclear weapons the attacking nation possesses, the accuracy and reliability of their delivery systems, and the effectiveness of the US's own missile defense system. The last factor is especially important given the recent proliferation of highly advanced ballistic missiles. But before diving into the country's missile defense systems and how they work, we'll need to first understand what they're guarding against. So let's start with the design of ballistic missiles. Ballistic missiles are sophisticated weapons designed to deliver warheads over long distances following a specified trajectory. The long-distance part is key here, as that's precisely what makes ballistic missiles different from other strategic missiles, that and their speed. However, not all ballistic missiles have the same operational range or the same speed. When it comes to the range, ballistic missiles can be broken down into 4 categories: short range, medium range, intermediate range, and intercontinental missiles. Here's a breakdown of how far each of these ballistic missiles can travel. Short-range ballistic missiles, or SRBMs for short, can travel up to 300 miles. Medium-range ballistic missiles, MRBMs, are effective from 300 to 600 miles. Intermediate-range ballistic missiles, IRBMs, have a range between 600 and 3,300 miles. Intercontinental ballistic missiles, ICBMs, can reach over 3,300 miles. As of 2024, Russia possesses the intercontinental ballistic missile with the longest range. The missile in question is the R-36M, and it can travel almost 10,000 miles, which puts the entire US within its striking range. To make matters worse, most of the remaining intercontinental ballistic missiles in the top 5 are also produced by the US's adversaries. At the number 2 spot, we have China's Dongfeng 41, which can reach up to 9,300 miles. The number 4 spot also goes to China thanks to its Dongfeng 5A missile, capable of hitting targets 8,000 miles away. The number 5 spot is held by North Korea and its Hwasong 15 missile, which can also reach 8,000 miles, but with a reduced payload. You'll notice we skipped the number 3 spot. This is because it's the only spot in the top 5 where the US shows up with its land-based LGM-30 Minuteman III missile, boasting an operational range of roughly 6,000 plus miles. That's 5,218 nautical miles. Remember the name, as these missiles are the backbone of the land-based prong of the US's nuclear triad, an instrumental structure in the country's nuclear deterrence strategy. But for now, let's get back to the basics surrounding ballistic missiles. We've covered range, so now we'll focus on speed. In that regard, missiles can be subsonic, supersonic, or hypersonic. Most short-range and some medium-range ballistic missiles are subsonic, meaning that they travel at a speed lesser than that of sound, which is around 761 miles per hour, or Mach 1. Most of the remaining ballistic missile types are supersonic, which means they can travel faster than the speed of sound. However, there are also ballistic missiles that can travel at a hypersonic speed, which is Mach 5 or faster. In other words, these missiles can travel at least 5 times the speed of sound. At least is the key word here, as the most advanced ballistic missiles can blow these numbers out of the water. Just take the previously mentioned Dongfeng 41 from China. Reportedly, the missile can reach a speed of Mach 25. But if it's any consolation, the US's LGM-30 Minuteman III isn't far behind, being able to achieve the speed of Mach 23. Given all the information you now know about the intercontinental ballistic missiles, you probably won't be surprised by the fact that these missiles represent the biggest threat to the US. Due to their weight, speed, and carrying capacity, these are the missiles that can deliver nuclear warheads the furthest distance. But what exactly does their path look like? Intercontinental missiles, like all other ballistic missiles, follow a trajectory that consists of 3 phases. Phase 1 is the boost phase. This phase starts at launch and lasts between 1 and 5 minutes. That's how long the missiles need to gain the necessary velocity to reach its target. Phase 2 is the mid-course phase, the longest part of the missile's flight. During the mid-course phase, the missile is traveling relatively steadily toward the target. In the case of intercontinental ballistic missiles, this phase can last around 20 minutes, depending on the missile's range. Phase number 3 is the terminal phase. This phase, which lasts under a minute for ICBMs, is when the missile barrels down on its target. With a little pull from the Earth's gravity, the missile reaches peak speed during this phase, making it virtually impossible to intercept. Judging by the description of these 3 phases alone, it's easy to conclude the best time to take out an incoming missile using ballistic missile defense: during Phase 2. Not only is the mid-course phase the longest, but it also sees the missile in its most vulnerable position, owing to a relatively flat trajectory and a predictable path. So it's no wonder that most US defensive systems are designed to strike during this phase, increasing the likelihood of a successful interception. However, the US isn't the only country aware of the fact that a missile is most vulnerable during its mid-course phase. So are other nuclear powers like China, Russia, and North Korea. That's why these countries have been working on developing countermeasures to evade a successful interception during the mid-course phase. These measures include programming the missile to fly to parts of the Earth that aren't covered by US radars and developing maneuverable missiles that can weave during the flight, thus increasing the difficulty of interception. After all, most interceptor missiles aren't equipped with radar. Instead, they rely on sea or ground-based radar systems for tracking the target, which can severely impact their accuracy. So how does the US deal with these challenges? By employing a multi-layered missile defense system, that's how. The layer in charge of dealing with all the issues concerning radar coverage is the Aegis Combat System, ACS. This state-of-the-art system employs a network of radars, sensors, and interceptor missiles deployed on naval vessels, most commonly destroyers and cruisers. The combination of ship-based radars and missiles makes Aegis a comprehensive defense system that can protect the ship itself, nearby vessels, and land-based objectives. Let's take a closer look at this combination. First up, the radar, aka the heart of this Aegis system. The Aegis system is equipped with the SPY radar system, which is one of the best air defense radars on the planet hands down. Although we'd like to list all the features and capabilities of this incredible radar, we can't. Why not? Well, most of them are classified, which should let you know how serious a piece of technology it is. But what we do know is enough to paint quite a remarkable picture. The latest iterations of this radar can perform air and missile defense on as many as 7 classes of ships, including destroyers, frigates, aircraft carriers, and amphibious warships. However, they are most commonly installed on destroyers, as the US Navy possesses a designated ballistic missile defense fleet of about 75 destroyers, which have a better Aegis baseline. Spy radars display the same versatility when it comes to the type of threats they can defend against. This includes ballistic missiles, cruise missiles, hypersonic missiles, hostile aircraft, surface ships. They can also hold their own during electronic warfare, ensuring the Aegis system remains operative even under these challenging conditions. Each spy radar system consists of several radar modular assemblies and self-contained radar antennas that stack together to provide continuous 360-degree situational awareness. However, the area where the spy radar system truly excels is the frequency with which it operates. This element is crucial for ballistic missile defense, as hitting the right frequency can make or break a defense mission. Go too low, and there won't be enough fidelity to accurately track and intercept the missile. Use an overly high frequency, and bid farewell to the maximum range of the radar. Thanks to decades of research and development, the spy radar system has achieved an optimal frequency that strikes the perfect balance between accuracy and range. So that's the radar part of the Aegis system. What about the interceptor missile part? Can it measure up? The answer is a resounding yes. The missile in question is the Standard Missile-3 SM-3, an exo-atmospheric interceptor designed specifically for ballistic missile defense. What makes these missiles unique is that they can operate in the vacuum of space. This relatively new missile employs a hit-to-kill kinetic vehicle to intercept ballistic missiles during the mid-course phase of their flight path. They can be ship and ground launched, which is why they're installed on the Mark 41 vertical launching system cells on both Aegis ashore sites and Aegis-equipped ships. Once launched, the latest iterations of this missile can reach speeds of Mach 13 and travel up to 1,550 miles. Though any more detailed characteristics are also classified, we know one thing. These missiles can shoot down ICBMs, as demonstrated by a highly publicized 2020 test launch. During this test, conducted at a facility northeast of Hawaii, the US Navy sailors aboard the USS John Finn successfully intercepted and destroyed an ICBM threat using the Standard Missile 3, Block 2A. More importantly, the USS John Finn destroyed the missile while simultaneously following other inbound air contacts. The latter part matters because it mimics real World War scenarios. But as perfectly executed as this test was, it has one major flaw. It demonstrated the effectiveness of the Aegis system against only one incoming missile. And what are the chances the US will be attacked with a single nuke? Virtually non-existent. If the US is attacked, dozens if not hundreds of nukes will no doubt fly its way. That's why it isn't enough to have the Aegis system only installed on naval vessels. One destroyer assigned to take out is a ratio that will do little to protect the homeland. That's where shore-based Aegis systems come into play. As already mentioned, these shore-based sites are known as Aegis Ashore installations. For now, the only known installation in the US is located at the US Pacific Missile Range facility in Hawaii. However, there are also Aegis Ashore sites scattered internationally, primarily in Devastation, Romania and Redzikowo, Poland. There were plans for Japan to become home to two of these sites, but they were scrapped in 2020 due to concerns over the accuracy of the Standard Missile 3 Block 2A interceptor missile and the overall cost of the project. The European Aegis Ashore sites can be used to take out any nukes shot at the continent, eliminating the need for the US to set a defense system in places like the Mediterranean, Black Sea, and Baltic Sea. But nuclear threats against Europe and the rest of the world aren't the topic of this video, so let's go back to protecting the US homeland. There are two more defense systems owned by the US Army that can be used to defend the homeland against a nuclear attack. First among them is the Ground-Based Mid-Course Defense (GMD) system, previously known as National Missile Defense (NMD). The previous name of this system speaks volumes about its importance in protecting the homeland. It's the primary system that can protect the entire US homeland. As its current name suggests, the GMD system is used to eliminate inbound threats during the mid-course phase, aka the most vulnerable phase during a missile's trajectory. But how does the GMD system take out a threat? Pretty much like the Aegis system. The GMD system also contains a series of ground-based and sea-based radars, offering accurate targeting data. It's easy to see how this system works. The inbound threat is tracked by the radar, the tracking data is aggregated and fed to the command center, a defensive interceptor missile is launched with the goal of, as the US Army describes it, hitting a bullet with a bullet. With the basic premise out of the way, let's dive a little deeper into the crucial components of the GMD system. First up, the radar. Or radars to be precise, as there are several types of radar used in the GMD system, each playing a specific role in detecting, tracking, and intercepting incoming threats. The mobile forward-based X-band radar delivers crucial tracking data to the GMD system, as it's designed to detect a missile as close to the origin country as possible. The upgraded early warning radar aids in detecting and tracking ballistic missiles during their mid-course phase. This radar is also used for threat versus non-threat determination. And finally, the ground-based radar, GBR, is a highly precise radar used to provide kill assessment. Next up, the Exo-atmospheric Kill Vehicle, EKV, aka the actual interceptor component used to take out the incoming threat. The EKV installed within the GMD system relies on various computers and color sensors to guide itself toward the target. When it reaches the target, it uses brute kinetic force to ram itself into it and destroy it. We also must mention the bases from which the EKV is launched. There are two of them, and they're located at Fort Greely, Alaska, and Vandenberg Space Force Base in California. These two bases have a common purpose: to intercept and destroy nuclear-armed missiles bound for the US. Together, these two bases have 44 interceptors, 40 in Alaska and 4 in California. For every interceptor, there's a missile silo and a silo interface vault, which is an underground electronics room next to the silo. Now, as sophisticated as the GMD system sounds, it does have a few drawbacks. The first, and undoubtedly the most important, is its success rate. Unfortunately, this system has proven to be only about 55% accurate in highly scripted tests. This percentage refers to scenarios when only one interceptor is fired. For this percentage to be close to 100%, at least 4 interceptors must be fired against the incoming threat. Another important drawback is the location of the existing bases. They're both on the west coast. Though some research has been conducted on the necessity of an East Coast site, the DoD claims that there isn't an operational requirement for it yet. If the site is to be built, it'll probably be at the Fort Drum Military Reservation in New York. The last missile defense system we'll discuss is located some 1,500 miles away in Texas. The system in question is called the Terminal High Altitude Area Defense, or THAAD for short. What primarily differentiates THAAD and GMD is that the former system is designed to shoot down ballistic missiles in their terminal phase. Given that this phase takes place as the missile approaches its target, it shouldn't be surprising that the THAAD system has a significantly shorter range than GMD. This system has had 100% success during testing. Unfortunately, this success rate doesn't apply to shooting down ICBMs in their terminal phase, as this has yet to be achieved by THAAD. As of 2024, the US Army possesses 7 THAAD batteries, 5 of which are installed in Texas. The remaining 2 are located in Guam and South Korea. The best part of these batteries is their mobility. These self-contained units can easily be transported to any location that might require point defense. However, it's important to note that setting up a single THAAD battery takes several days, as it consists of multiple components that need to be assembled and calibrated on site. These components include internal radars, fire control and communications (THCC) computers, 8 interceptor missiles, 6 missile launchers, support equipment. Generally speaking, the THAAD system behaves similarly to the GMD and Aegis systems. It employs a kinetic warhead to destroy any incoming threats. But how effective would these 3 systems be in a real-world scenario? In other words, could these systems defend the US against a nuclear attack? In theory, they could. However, the issue lies in the number of potential nukes heading toward the US. Let us explain. As tests have shown, only the Aegis system can achieve the perfect 1-for-1 ratio. In other words, one Aegis-equipped ship can take out one incoming missile. THAAD and GMD systems can't. So let's crunch some numbers to see how many missiles the DoD could stop from reaching the homeland. The US Navy has 150 SM-3IA and 182 SM-3IB interceptors that are part of the Aegis system. The US Army possesses only 44 EKVs available for launch in the ground-based mid-course defense system. There are 5 THAAD systems, with 6 launchers and 8 missiles each. This comes out to 240 interceptor missiles. So all in all, the US has about 784 interceptor missiles it could use to attack incoming nukes. That number rises to 880 if the 2 THAAD systems stationed in Guam and South Korea are made operational again. But let's assume that the nuclear attack is imminent and the US can only rely on the currently available interceptor missiles. So 784 of them it is. Under ideal circumstances, these interceptors could take out 784 nukes, making their way to the US. But as already explained, the GMD system is far from the perfect 1-for-1 ratio. So let's say 4 GMD interceptor missiles are needed to eliminate one incoming nuke. This means that the GMD system alone could only take out 11 nukes. Since the THAAD system has a higher success rate, let's say 2 THAAD interceptors are required to destroy a single nuke. After crunching the numbers, we can conclude that this system could successfully deal with 120 nukes. As for the Aegis system, let's hypothesize that it can achieve the 1-for-1 ratio as it did during tests. So does this mean this system can take out 500 incoming missiles? Well, not quite. Remember, the Aegis system must be installed on a naval vessel. When combined, there are more than 100 Aegis-equipped ships in the US fleet. So in the case of an imminent attack, the Aegis system could destroy about 100 nukes. Add the numbers from all 3 systems up, and you get a total of 231 nukes that the US could successfully prevent from hitting the homeland. Though DoD would probably employ other systems in the event of a nuclear attack, such as the Patriot missile batteries, we'll take this figure as the worst-case scenario. Now, this number might seem adequate at first glance. However, it definitely won't once you hear the number of warheads the US adversaries currently have in their nuclear arsenals. As of 2024, Russia alone possesses about 5,580 nuclear warheads, making it the #1 nuclear power in the world. This means that Russia would only need to launch a meager 4% of its nukes to overcome the US's defenses. Luckily, no other US adversary boasts such a colossal number of nuclear warheads. Only China could endanger the US, but it would have to launch virtually all of its nukes. North Korea and Iran, on the other hand, couldn't do it even if they combined forces. But let's not forget, these predictions are strictly based on numbers. However, the number of launched nukes is only one element of successful defense. The other is the type of nuclear warheads and missiles launched. And things aren't looking too good for the US in this department either. Though Russia is already the biggest threat based on numbers alone, its nuclear technology also warrants a separate mention. Russia possesses a wide variety of warheads, most of which are capable of inflicting unacceptable damage to the US homeland. Arguably the most dangerous among them are the so-called exotic nuclear weapons that have confounded Western analysts. This includes a nuclear-armed anti-satellite weapon that could take out satellites orbiting in space. The development of this weapon is particularly worrisome, as nuclear tests in the atmosphere and space are forbidden for a reason. A 1962 US missile test, referred to as the Starfish Prime test, hurled a 1.4 megaton warhead into space, damaging at least 8 satellites in orbit. Since satellites are so crucial for missile defense, this kind of interference could give Russia a chance to strike the continental US while the comms are down. Russia is also continuing to build and modernize all 3 legs of its strategic nuclear triad: nuclear-capable ICBMs, submarines, and bombers. In addition, Russia's non-strategic nuclear weapons aren't far behind, with a variety of nuclear-capable torpedoes, depth charges, and short-range missiles they can choose from. The more Russia is losing face in Ukraine, the closer its President Vladimir Putin is to pushing the infamous nuclear button. And it's not like we're guessing, Putin has literally proclaimed this himself. He keeps reminding the West that Russia is one of the leading nuclear powers in the world and that messing with the country can result in grave consequences. And since Russia sees the US as the #1 enemy, you already know who these missiles are pointed at and who would take the brunt of these horrifying consequences if tensions were to escalate further. Though China and the US aren't currently on the same level of animosity, a nuclear threat coming from this country shouldn't be taken lightly either. Not when China has been tirelessly working on expanding its nuclear arsenal, aiming to possess 1,000 warheads by the end of the decade. China is also big on producing intercontinental ballistic missiles with hypersonic glide vehicles, which could be virtually impossible to stop. North Korea and Iran might be far off number-wise, but this doesn't make them any less of a threat. North Korea is particularly worrisome, as its supreme leader Kim Jong-un is just as erratic as Putin, if not more. He too has threatened a nuclear strike on several occasions, intensifying this rhetoric since he declared North Korea a nuclear weapons state. So as you can see, there's no shortage of nuclear threats coming from around the world. However, there's undoubtedly a shortage of effective defense interceptors in the US that could deal with an intense nuclear attack on the homeland. Of course, if a nuclear attack on the US were to happen, it would all but guarantee the destruction of the world as we know it. After all, one can't just drop a few nukes on a country and carry on as if nothing happened, regardless of how the country defends itself. So for the sake of global survival, let's hope the increasing number and complexity of nuclear weapons continues to serve only as deterrence. Now we pass the questions to you. What's your take on the probability of a nuclear attack on the US? And if this attack were to happen, would the US be able to defend its homeland? Share your theories in the comments section below. Now go and check out Russia's top nuke targets or click this other video instead.